Let us discuss how metal carbonate respond to the action of heat. That means I am here to study thermal decomposition of metal carbonate. Now, the carbonates of sodium and potassium, they are very stable to heat, just like their oxides as well as their hydroxides. So the carbonates of sodium and potassium, they are stable to heat. They do not undergo any kind of decomposition even if you heat them very strongly. Even if you heat them very strongly. But the carbonates from calcium till copper, carbonates from calcium till copper, when you heat it, it decomposes to give me corresponding metallic oxide and colorless, odorless gas which is acidic in nature, that is carbon dioxide. Now, as usual, the carbonates of mercury and silver, these are the main culprits actually. They show difference in behavior. So our focus should be on what difference in behavior is been seen. So the carbonates of mercury and silver, when they are heated, in place of giving metallic oxide, they give metal as a solid product. Along with that, I got colorless, odorless acidic gas, that's carbon dioxide, and colorless, odorless neutral gas, that is oxygen gas. Okay, so let us start our journey towards understanding the reaction of metal carbonates from activity series. So let me have the reaction for potassium first. So the carbonate of potassium, that is K2CO3. So if I heat it, I get K2CO3. No change because it is stable to heat. Same way, I'm having Na2CO3. This is also when I heat it, no change, Na2CO3 remains Na2CO3 only. Then I'm having CaCO3, that is calcium carbonate, which is commonly known as limestone. When I heat this, I get calcium oxide plus carbon dioxide. Calcium oxide, as we know, it is called as quicklime. Then I'm having magnesium carbonate, that is MgCO3. If I heat it, I get MgO plus CO2. Then I'm having aluminium carbonate, that is Al2CO3 thrice, aluminium carbonate. So when I heat it, I'll get Al2O3 plus CO2. So to balance this particular, I'll multiply here by 2, here also by 2, and there are 3 2s are 6 carbon, so I'll multiply this by 6. Then I got here zinc carbonate, that is ZnCO3. When I heat it, it gives me ZnO, zinc oxide, plus carbon dioxide. So as we know, in earlier cases also we have written the oxide of zinc is yellow when hot and white when cold. Okay. Now, next we have the oxide of iron, that is FeCO3. FeCO3, if I heat it, I get FeO, that's ferrous oxide, plus carbon dioxide. Then lead carbonate, PbCO3, when heated, it gives me PbO, as in yellow litharge, plus carbon dioxide. I have copper carbonate, CuCO3, which is light green in color. If I heat it, it gives me CO, copper oxide, which is black in color, plus CO2. Now, the changes which have been seen here, that is for mercury. So I have HgCO3. When heated, gives you a metal in place of metallic oxide plus carbon dioxide plus oxygen. Okay, so if I have this to balance, let me multiply this by 2. So I've got 2 mercury metal, 2 CO2 and oxygen. So it got balanced, 6 oxygen atoms. Then I take silver carbonate, that is Ag2CO3, because carbonate is bivalent radical and silver is monovalent. When I heat this, I will get silver metal plus carbon dioxide plus oxygen. To balance this, 2Ag2CO3, 4Ag, and this is in 2. So this is about decomposition of metal carbonate. The carbonates of sodium and potassium, they are stable to heat. The carbonates from calcium till copper, when heated, they give you corresponding metallic oxide and carbon dioxide. Whereas the carbonates of mercury and silver, when they are heated, they give me corresponding metal, carbon dioxide and oxygen gas. Thank you for watching.